Well, it sounds like it's got a lot of stuff in it. This was actually, I was here in the afternoon because I came after third hour. And the main question I got from the review was a lot of people looked at one of those review questions and it said for you to differentiate a question. And most people had no idea what differentiate meant. Who was the first person we're supposed to call in here?
Me.
What's differentiate?
Like, kind of like show the difference between two things, or like kind of.
Oh, you're giving me the actual English definition.
Yeah.
That's not wrong.
Oh, yeah.
Doesn't help in Celtic, but it's not wrong. Does anybody know what the Celtic version of what does differentiate mean? Wait, how did you guys do that question if you didn't know what it meant?
Like find
You just skipped the
derivative of
question?
it. Find the
Derivative. Differentiate is kind of like, I like to think about it as like the verb way of saying to take the derivative of. It's like the fancy way of saying derivative. I don't know why they have multiple words that mean the same thing. It's not my choosing. Differentiability, if you want to write something down for yourself, that's derivative. That's the posh way of saying derivative. Oh, I thought there was actually something. Okay. All right, Onyx. Pick somebody. Oh, wait, I forgot. You were like, yes, okay, it's coming. There's that. There's that.
Olivia.
So that little boxed in area that says differentiability at a point. I'm hoping we've done this enough by now that you can read the notation. This says something, and this says something. Do you remember what either one of those mean? Because they're kind of the same thing-ish.
Like what the formula is?
I don't know. What does it stand for? What is it finding?
The prime.
Oh, sure. Yeah, derivative. That's what the prime is, the derivative. So f prime means, derivative means slope. Yeah.
Does it mean find the derivative from the left and right?
Perfect. So the minus and plus. This means slope on the left should equal the slope on the right. So what you guys want to get to the point of is you want to get to the point where you can look at this box, see this terrible notation, and then be able to like understand what it's even trying to tell you. Because that's partially what makes this class difficult, is there's just so much notation. And it says it has to equal L, where L is a finite value. So that basically just means it has to be a number. Okay, so slope on the left, slope on the right means that it has a derivative so differentiability just means, is it able to have a derivative? If you run into the wording that says not differentiable, because that's what a lot of these questions are. Look at how much space this takes up. Not differentiable means a derivative is not possible, or the derivative doesn't exist. Oh, I screwed that one up. So there's gonna be a variety of different questions that all say the same thing, but use told all sorts of different words and terms. If you're asked, where is this function not differentiable? It's basically saying, is there a spot on this graph or equation that you aren't able to find a derivative? And if it asks where it's differentiable, that's asking you where would you be able to have a slope answer? Okay, so this one, we have a graph slash have an equation. This is leading us to this spot. What is the slope on the left-hand side of 1? So, -1. The left-hand side of the V has a slope of -1. Then it says, what is the slope on the right-hand side of 1? That's +1. Oh, I guess we do need to call it somebody else now.
Pick someone.
Sure.
Trevor? I'll just pick somebody. Trevor?
Trevor, is F continuous at 1, like looking at that picture? Do you want a reminder of what continuous? Okay, so continuous, can you draw it without picking up your pencil? Yeah, yep. Correct, there's no holes, there's no gaps. So it's continuous. Is F differentiable at 1?
Yes.
Oh, you're gonna answer? Okay.
Yeah, that's right. Because it's.
That definitely sounded like a question to me, but.
Well, are we saying that a 0 slope is still a derivative? Because it doesn't have. Slope is 0 at 1.
Okay, that big giant box at the top of the page,
Yeah.
what did it say the definition of differentiable means?
As if they're equal.
The slope
And
from the
slope.
left and the slope from the right, are they equal?
No.
No.
Okay.
Correct. So since these, how am I gonna write that? Not equal to each other, this is a no. Now, from this picture, this is supposed to teach us that sharp points do not have a slope. We're gonna run into sharp points frequently. But this is the definition reason of why they don't have a slope, because the slope on the left and right is totally different. Good Lord, I can't spell slope. Slope. Doesn't exist. I just didn't have room to write that. Phone. You're messaging during the most interesting
I'm not
topic of all.
I was seeing one of his classes over
I'm not sure how that's better.
it. It's 10:06.
It is 10:06.
I can't see that far away.
Okay. Okay. We also have a right issue.
Oh. I really do learn something new every day.
That's because I can't remember any of the time, so I have it all over the place in the room.
I don't want to know that.
Oh, yeah, you're right. I erased that last hour because I realized it was the wrong day. Okay, given the graph of cube root of x, use the alternative form of the derivative to show that the function has a vertical tangent line at x equals 0. Oh, yeah. Okay.
Owen.
I feel like you're just choosing people now. I'm not hearing any rolling. Owen, I was hoping you could help me fill this out. It's gonna be at x equals 0, so that would be the c value.
Alright, so it would be, cube root of x minus 0 over, x minus 0.
Good.
Or x.
Okay. Pause there. Next person.
Spencer.
This was actually one of the first questions on your review yesterday. Why is Owen's limit incorrect? It's a technicality, but it's a big technicality. And I'd mark it wrong on your text, which some people got marked wrong on their text.
Is it because C
I don't know what that means. It's a good get. I mean, it's a good logical sounding answer. It's a super obvious answer once you see it.
Richard didn't have the limit of x.
Didn't write the limit. This was question number 1 on your review. It's very easy to forget to write that. Okay, I can't plug 0 in. And I don't need to write minus 0. So what do I do? Anybody have any thoughts? I don't know if I want to call on somebody specifically. Why does this have an undefined slope at 0? That's what we're trying to do. A vertical tangent line means that your slope doesn't exist at 0.
Is it because you have to put numbers in to solve if x is 0, you can't divide by x?
Yeah, I mean, there's a variety of ways we could probably prove this and show this, but it's basically because 0 is on the denominator. And even if I combine these together, these would combine together to be 1 over x to the 2/3. Because you've got x to the 1/3 on the top, you've got x to the first on the bottom. And if you take 1/3 minus 1, you get negative 2/3, which is that. So this would essentially show that you have like a vertical asymptote in your derivative at 0. And so then that would mean the derivative doesn't exist at 0, and that's what this shows. The derivative doesn't exist. So it is undifferentiable at x equals 0.
Instead of writing all that, can we just write f prime dne?
Yeah. Yeah, they mean the same thing.
Alright, sounds good.
I'm just trying to purposely use this wording because you're gonna start running into it a lot, and I want you to see the word and not like pause and try to think to yourself what it means.
Would you say like f prime and 0 does not exist?
Sure? Wait, what did you say?
F prime dne does not exist.
Oh, that's actually not accurate. I guess I wasn't really fully paying attention. F prime exists a bunch of places.
Oh,
It doesn't exist at 0. So if you wrote f prime of 0 equals dne, that's okay. He was pretty excited about it too. Okay, now the next thing. In that first example, it was trying to teach you, show you, being continuous does not guarantee something is differentiable. Both of these problems are examples of that. They're both continuous, but they both have a spot that doesn't have a derivative. However, the other way around does. If you know something is differentiable, like, can you find a slope? It guarantees that it's continuous at that location. So you are gonna have questions that would be the case. Okay. Nah. Okay, this is kind of what I just said out loud. I guess it was on the next page. Being continuous doesn't mean you're gonna have slope. But the opposite is absolutely true. If you have slope somewhere, you're guaranteed it's continuous. And that's pretty much because if you have slope, you have a limit from the left and the right of the slope, which means it has to have spots there to be able to have slope. Ooh, a contrapositive. I have not heard that word since geometry. I feel like there was a science class we had to use that for too, wasn't there? Like, which science class do you have to prove stuff?
Science class, ninth grade.
I mean, it's sort of true anyway, but, I remember one, maybe that was in college. I felt like it was chemistry for some reason.
I mean, every science is gonna make you prove something one way or another.
That's true. That is very true. You guys are gonna get to the pH scale in chemistry, and you'll have to prove that the pH scale actually works on derivatives and limits. Yeah, that's good stuff. Calc is the basis for all the different science classes. Okay, describe the x values at which the function is differentiable. Justify your answer. Okay, let's actually roll.
Benica?
Bianca?
Bianca.
Oh. I was gonna say, I don't remember Benica. Okay,
Wait, what was the question?
says right there.
Okay, I don't know.
Oh, all right. I guess Brooke's not the only one checking what time class ends. Wait, what time does it actually end? Okay. Do I need to get you guys more involved, like up at the board, so we wake up and like are invested? Oh, that is like a scared look. Why are you guys so scared to come up to the board? Why is it imposing?
Isn't it not
Well,
differential?
what is it you're answering for me?
Sorry.
Is it?
Actually, I really want to call you, what did you say again?
Bonica, I don't know.
Bonica? No, not Benica? Benica. I actually like that. Okay, so this is saying, where is this graph differentiable?
Is like at most points except for when it's like the track point, at like -2 and 2.
Oh, actually, it's not -2 and 2. This is it.
Well, like a little.
Yeah, you're 100% correct. It would be much nicer if this was x squared minus 4, so that it would be 2 and -2. So it's not differentiable. And we are answering the exact opposite, unfortunately, but we'll get there in a second. So it's not differentiable at x equal plus and minus square root of 5. Close to 2-ish. So if we want the quick way, which is exactly what you were trying to answer, the quick way of saying where it is differentiable, then we can say x not equal to plus and minus square root of 5. That would be the quick way of saying everywhere but those two. Now, if you want to do interval notation, you could say negative infinity, negative square root of 5, along with negative square root of 5 to square root of 5, along with square root of 5 to infinity. Everybody kind of has a preference on how they like to write things. Pick whatever. But excellent. So the only spots it doesn't is where there were sharp points. Should we move on to another example? Was that, I'm guessing this one was pretty quick to do. Otherwise, if you guys have questions, ask away.
Wouldn't zero also not be, because it's,
Yeah.
they're not equal at zero,
Because it's
Yeah.
switching direction.
because the slopes aren't equal on either side.
They're both zero. Oh, I got what you're saying. If you were to zoom in 100 times,
Hmm.
that top of the hill would look like a flat line.
Okay.
And so from the left and right, they would have the same slopes. But if you were to zoom in 100 times on a sharp point like this, it would actually still look exactly like that. No, I guess I did not even think of that. That's a good question. Are you guys okay with that? I never even thought of that part. Okay. Oh, no. Well, now we don't have a picture. Now we do, what are we gonna do now? All right, anybody have any thoughts? And no, I'm not planning on finishing this whole thing today. I don't think we'll do it.
Can you do like the limit from the left of zero and then the limit from the right of zero? And then see if those, and then,
You have a very good idea. Unfortunately, what you're thinking of in your head, the limit idea is the great idea. But the limit would just tell us the height of the graph, not the slope.
oh, I mean, find the derivative
Oh,
from
oh.
the left and then from the right of both.
So you want to find the derivative of all three things first?
I don't know, maybe?
That's totally fine. I was just asking. That absolutely method would work,
Is that the long way?
for sure. I mean, we'd have to find
Plug
three
the numbers
derivatives.
in?
What?
You plug the numbers in and see if it's continuous first.
Oh, that's good thought. Because if it's not continuous, you're guaranteed it's not a slope. Okay, so let's find that first then. So at zero, we would have 1 and 1. All right, it's continuous at 0. So 0 is out. 3, 6, 7. Ooh, this is probably not going to be 1. It is not continuous at 3. And that, do you guys want me to say why it wasn't a 3? Were you okay figuring that one out? This one has a height of 7, this one has a height of 1. So they are not even close to the same. Okay, so not continuous at 3, automatically not differentiable at 3. Okay, there's one spot. Now, your first idea is actually going to be ideal and perfect when you figure out how to do derivatives really fast, because that's just easy.
With the, why would it not also be continuous at 3, just because they both have on the top and bottom of that, greater than or equal to? I just might be an old question.
Wait, back that up, say it again?
So the 0 has the x equals greater than or equal to?
Yep, but this 0 does not.
So would it, it's still continuous at 0 because of that, right?
Oh, gotcha, yes.
Or, and then why
So,
would the 3 not be? If
Okay,
it's based off that?
different things. So, if this did not have the line underneath it, it wouldn't be continuous because there would be a hole, for sure.
Yeah.
This one's not continuous, nothing to do about the line or not. This one has a height of 7, this one has a height of 1.
Oh,
So, it wouldn't matter which one had the line, they're just at different heights.
okay.
Yeah, no, you're correct, that's just a different, thing. Okay. Does each of these individually, so this is a parabola, correct? Okay, would a parabola have any spots where you couldn't find slope? No. Straight line, no, that's just one slope. Parabola, no. So all three of these individually aren't going to have any random places that wouldn't have a derivative. like if we had if we had a vertical asymptote or something like that, that's definitely one thing we would look for, something weird. So I guess the last thing we need to do is we need to check if they have the same slope at 0. So there really isn't much else we can do, except for try that now. And all that does at least is just save us the derivative of one thing. If I can cheat a little bit, let me just tell you the derivative at each spot. So the derivative for x plus 1 squared will be 2x plus 1. The derivative for 2x plus 1 will be 2. So if we want to find the slope from the left of 0, I'm going to plug 0 into here, which would give me an answer of 2. This is terrible notation. Now they have the same slope on the left and the right. So it is differentiable at x equals 0 because they have the same slope left and right. So this one, the actual original question was saying find out values of x for where it's differentiable. We found the only place that it's not is at 3. So we could answer differentiable at everywhere but 3. Okay, now without going too much farther, because there's going to be a lot of details, and so I wanted to go over the rest of the notes tomorrow with you guys. You are welcome to start the homework, because you'll be able to do about probably half of it, even though they're all mixed together and it's annoying. So if you run into a homework question that you don't understand or don't know, obviously just don't do it yet. But you should be able to do definitely some of it. Again, if you wanted to come to R&R to do corrections from the second test, go for it. If you want to come to R&R just to get help, that's fine. There are going to be some people doing retakes today, and I'll probably not have them do it in my room, because I think Mr. Caponigri has his room for retakes on Tuesdays. I don't know, just ask away if there's things you want. Are we trying to rewire light here? That's just not still our packet in fire. That's all I'm worried about.